Okay, so now let's explore infinite limits. Let's calculate, or let's evaluate the limit as x approaches 2 of 1 over x minus 2. So how would we solve for this limit? If you directly substitute 2 for x, you get 1 over 2 minus 2, which equals 1 over 0. If you see a non-zero number like 1 divided by 0 while directly substituting, that means you have a vertical asymptote at x equals 2. So we have to now look at how the function behaves around x equals 2, whether the left-hand side and the right-hand side both go to infinity, or both go to negative infinity, or they go opposite directions. So we need to watch the single-sided behavior now. So how do you evaluate the limit as x approaches 2 from the left-hand side of 1 over x minus 2? We can sort of look at the trajectory of this function by plugging in values of x that are closer and closer to 2 but are less than 2. So we can plug in a value like 1.99 into this function and see what that function equals. It appears to equal 100. If you plug in a value even closer, 1.999, into this function, we get 1 over negative 0.001, which equals negative 1000. So, looking at this trend, we can see that the function is just gonna approach negative infinity, because as x approaches 2 from the left hand side, the denominator is gonna get smaller and smaller and smaller in magnitude. All right, that's going to result in this function's magnitude going all the way to infinity. But remember, because x is coming from the left-hand side, this denominator is going to be a negative number, which means that the whole function is going to become negative infinity as you approach 2. So we'll just say that the limit as x approaches 2 from the left-hand side of 1 over x minus 2 is negative infinity. We can apply the same logic to evaluate the right-hand side limit of 1 over x minus 2. All right? So let's plug in values of x that are really, really close to 2 but are greater than 2. All right? So you plug in 1 over 2.01 minus 2, you get 1 over 0.01, which equals 100. All right? If you plug in even closer values of x, like 1 over 2.001 minus 2, that's just going to equal 1 over 0.001. That's equal to 1000. Okay, so now looking at this trajectory of the function as we get x values closer and closer and closer to 2, we see that this function is now going to positive infinity, right? The denominator, yes, it gets closer and closer to 0 in magnitude, right? As x approaches 2. Because x is greater than 2, this denominator is going to be positive, and that's going to mean that now the limit is positive infinity rather than negative infinity before. Because the left-hand side and the right-hand side limit don't equal each other, the two-sided limit, the actual limit, as x approaches 2, doesn't exist. Okay, so now let's explore limits at infinity. If I give you the limit as x approaches negative infinity of 2x cubed minus x plus 1 divided by x squared plus 1, how would you evaluate that limit? Well, if you directly substitute negative infinity here, you would get negative infinity over infinity, all right? So that does not work. What you're gonna do is you're going to basically circle the term with the highest power in both the numerator and the denominator, and then evaluate a new limit. So the limit as x approaches negative infinity of just the terms with the highest degree. Okay? This limit is the same as this limit. Always, when you're evaluating limits at infinity. Okay? This is a little easier to solve, right? Because that is just the same as the limit as x approaches negative infinity of 2x. All right? You cancel out the x squared from both the top and the bottom. And what does that give you? That gives you negative infinity. Okay? Okay, now let's try the limit as x approaches negative infinity of negative 2x squared plus x minus 1 divided by x squared plus 1. Okay? We're going to do the same thing. We're going to circle the term with the largest power. Then just going to create a new limit as x approaches negative infinity of negative 2x squared divided by x squared. Okay? Now, you can just cancel out the x squared from both the top and the bottom, and you just get limit as x approaches negative infinity of just negative 2. And that's just, when you take a limit of a constant, you just get the constant back, because here x is not doing anything to the function y equals negative 2. All right, now let's evaluate the limit as x approaches negative infinity of the square root x squared plus 1 divided by 2x. How would you do that? If you plug in x negative infinity for x, you would see that this would become an indeterminate limit, okay? So, how would you do this? How would you solve this limit? You will just circle, first you just circle the terms with the highest power, okay? And you do the same strategy, all right? So you'll rewrite the limit as x approaches negative infinity of x squared divided by 2x. Hold up, wait just for a minute, okay? I shouldn't get ahead of myself too much, all right? So, a mistake I made here is that because the x squared is actually under the square root over here on the function to the left, I also got to do that on the right side, okay? So just make sure that you don't forget to do that, okay? So, now my new limit is the limit as x approaches negative infinity of square root of x squared divided by 2x, okay? So, now this is easier to solve, okay? The square root of x squared is equivalent to the absolute value of x. So we can rewrite the limit as x approaches negative infinity of absolute value of x divided by 2x. Okay? For negative values of x, the absolute value of x essentially just becomes negative x. Okay? Right? So if I have a negative value of x, like negative 10,000, if I multiply that with a negative 1, it just becomes positive 10,000, okay? It's doing the same thing the absolute value is doing. And that's just equal to negative 1/2, okay? It's very easy to get confused with all this absolute value square root stuff, okay? So yeah, make sure to be careful about how you do this. Okay, so now let's solve the limit as x approaches infinity of x to the 99 over e to the x. You see, now the bottom doesn't have a polynomial or any radical or anything like that. So how do you solve this? Well, if you have an exponential function like e to the x, 1.1 to the x, 2 to the x, 10 to the x, anything to the x power, you know that this function will always outgrow whatever is on top. It's always going to outgrow it, okay? So you can just assume that this limit equals 0, okay? Because e to the x is always going to outgrow x to the 99th power. So this limit will always equal 0, okay? Similarly, if I ask you the limit as x approaches infinity of 1.01 to the x divided by x to the 99 999. Okay, you might think that this will also approach 0, or at least something that's finite, but actually this equals infinity, because in the long run, 1.01 to the x power is always going to be approaching infinity. Okay, because in the long run, 1.01 to the x will outgrow x to the 999 power, so that's why it's going to equal infinity. Let's do one final problem where we sort of apply everything that we have learned. Okay, limit as x approaches negative infinity of 5x cubed minus the square root of x to the fourth minus 2x squared plus 1 divided by 7x cubed plus e to the negative x. Oh, sorry, e to the x. How would you evaluate this? Well, let's look at each term in the independently, okay? So if you let x approach a negative infinity of e to, and plug that into e to the x, you know that this is going to equal 0, right? E, like the limit as x approaches negative infinity of e to the x equals 0, right? It has a horizontal asymptote at y equals 0. Okay, so we can rewrite this limit as x approaches negative infinity of 5x cubed minus the square root x to the fourth minus 2x squared plus 1 divided by 7x cubed. All right. So now that we've rewritten this, we have to pick the term with the highest degree, with the highest power. You might be tempted to pick x to the fourth, but because it's written inside a square root, you're going to treat it like you're dividing it by 2. Like, you're going to treat it like it's square root of x to the fourth, okay? And that's like x squared, so that's not going to work. So we're going to pick 5x cubed as the term with the biggest power in the numerator, and 7x cubed as the biggest term in the denominator. 7x cubed is the only term in the denominator. So we set the limit as x approaches negative infinity of 5x cubed divided by 7x cubed. Okay, this whole square root doesn't matter because everything inside of this basically functions like a quadratic function, because the highest degree inside the square root is a function to the fourth power, but when you square root it, it basically acts and grows like a quadratic function, a function to the second degree. Okay, so you have 5x cubed divided 7x cubed. When you let x approaches negative infinity, you get 5/7.